Today, I will be talking about a hypothetical pathway that leads to the spikes in the ectoderm of beetles. To begin, the arrows mean that it's required to activate the formation of the next step, and the sideways T means it blocks or inhibits the next step. So, for example, the P activates the formation of the I, and the I inhibits the formation of the K. All right, so um, the first example is if the P is mutated. So if this no longer works, it can't activate the I, which means the I cannot block the K. So the K is going to be formed, and it's going to block the E still. So the E can't make the spikes, so no spikes will be formed. So next, if the I is mutated, so if the I doesn't work, that means it cannot block the K. So the K is going to be formed, and it can block the E, and that means no spikes will be made. Now, if the I and the E are both mutated, so if the I is mutated and the E is mutated, that means no spikes are going to be formed, because if the E can't be produced, then no spikes are going to be made. If the S and the K are mutated, then the S will not be able to activate the P, which means the P is not formed, so it can't activate the I, and if the I isn't made, it's not going to be able to block the K, but the K is also mutated, so it's not going to be able to block the E, so spikes will be formed. A possible reason why this pathway is here is because the ectoderm does form the outside layer of the beetle. It's also going to form other things such as the nervous system, and that wouldn't need spikes. So it's here, so the cells that do need spikes in the ectoderm get them, and the cells that don't need the spikes don't have them. So that's all. Thank you.